Hi, good afternoon, all of you. Yeah, hi. So I'm putting you on mute. Yeah, so I'll initiate the discussion now. So, welcome to this wonderful, insightful discussion that we are going to have today. So, I'm going to talk about data science. You know, you guys, either you are pursuing actuarial or you are into commerce, or basically, you are pursuing your graduation in BSc mathematics or statistics. Okay, so this is relevant for each and every audience who is sitting here. It's just that the people who come from commerce, they are more close to my heart because I am a commerce graduate. No biasness, please. Okay, so I'll not be biased at all, but then I'll tell you what is required here. Moreover, how is the future? If you're pursuing actual, then in fact you are actually sitting at the correct place and you are in the correct chair. Okay, let me tell you why. See, what tools that we use throughout in the field of analytics or data science, so to speak, okay, the knowledge comes from the same field in which you guys are studying CD3 probability and statistics. Statistics is very much required in the field of data science, and as a matter of fact, in the professional world, we call actuaries, uh, you know, a very renowned name for data scientists, because whatever the skill a data scientist acquires over a period of time, you guys are very good in terms of understanding theory. You guys have solved questions, so you have in-depth knowledge. The only difference is that we work exclusively on systems. We hardly deal with theory. You guys first of all deal with theory, then you come into the practical world, and that's the reason for actuarial students, IFOA has brought R into consideration. So 2019 R will be there, and that's the reason they're trying to bridge the gap between the theory and the practicals. Okay, so now the question is that why should I focus on this? Of course, the people who pursue actually, or the people who are actually pursuing their graduation in statistics or mathematics, they are very valuable people in today's world. Why? If you look into the data of the last 5 years, with the advent of smartphones and a lot of possibilities opening up when it comes to smartphones, and 4G coming, and then the plethora or the area of opportunities being increased like anything, the data being generated so much, so definitely there's a big scope, or in fact there's a huge scope of a lot of people who can initiate their career in the field of analysis. See, whether you work in insurance, whether you work for Amazon, or you work for a bank, or you work for an educational institution, data is everywhere, right? Because if you have data, you can analyze, you can see the patterns in the past data, and basis the pattern, you can analyze and you can predict that maybe, because I have started early. I give you a very simple example. I've started early preparing, so there's a high probability that I will clear the exam. Oh, you started preparing late, so there's a high probability that you may not be able to clear the exam, or you might be able to clear the exam but not very good marks, right? Okay, so that's what you know that this is a pattern, and basis that what is the outcome, or what will be the outcome be, right? Okay, just like the way this is a very simple example and related to the academia, or basically in the student life, that's the similar kind of examples we have in the in the business world. But business world is not that simple. Business is complex, and businesses are getting complex as the world is moving in the field of artificial intelligence. We are improving ourselves into that field. So artificial intelligence, machine learning, deep learning, data science, analytics, these things are actually there to help businesses make better decisions, automate the things, digitize the things, so that the human effort can be, not, I'll not say minimized, but human effort can be relaxed. Okay, so if something that I do and I take a lot of time, and within a fraction of a second a machine can do it in a much better way, so why not? When somebody asks me that why data science, and why this field has cropped up like anything, I the first and foremost thing that comes into my mind is the advent of wheel, or in fact the invention of wheel. So it's more or less like an invention of wheel that will transform the way the world looks like. And in fact in the past couple of years, mobile phone has changed the way the world looks like. Okay, so with this I'll start with the journey of data science, and I'll put you through this entire roller coaster ride. So this is me. So my name is Mukul Kumar Singh. I carry 11 years of experience in the field of analytics. My parent company had been GE. I worked for GE across, and I handled operations. I worked in training as well and quality as well. Right. Okay. I'm Six Sigma certified from Indian Statistical Institute. Therein, I got an opportunity to read and learn more about data science. Okay, and that is when I came to know that I was working into analytics, but then I learned that statistics is the backbone of analytics. You cannot analyze data if you don't have the knowledge of statistics. So statistics is the primary segment of your life. So I'm a CS, CFA, and graduation in commerce. Okay, and currently I'm running my own startup in Jaipur that focuses on immigration and H1 marketing people for US. Okay, so in fact, my clients there in US, they also talk about analytics, and they want us to analyze data. So we do it, but then not as a core, but yes, as an ancillary services, we do provide them insights. But then that is typically HR analytics. Okay, so today, if you look into this slide, and you just simply have a look here. So any industry that you think of, or any company that you can imagine of, is full of data. Data is everywhere. you know Even a small shopkeeper, if the person is able to maintain data, he will have tons of data. A small restaurant, or a popular restaurant across the street, will have amazing data of the customers, their preferences, their choices, their taste. And can we apply analytics just to predict what would the customer like? Can we maximize his satisfaction? That's what these tools are meant to be, so that we can make more revenue, decrease our cost, enhance the customer satisfaction, and can be termed as a single word: amazing. Right? Okay, that's what analytics do. That's what we do when we talk about analytics. Okay, so now, since every industry has tons of data, so we need a lot of people in the market, or we need a lot of people in the future who can analyze the data and make predictions correctly. Okay, so I'll give you step by step and an introduction to how exactly we do everything. But then this will be completely an overview of what our data science profile or a data scientist profile looks like. Okay, but the one thing is sure, as a matter of fact, that yes, nothing can be done without the help of the statistics. The statistics is the primary thing that you guys should know. And that's the reason, when I started this discussion, I said that yes, if you guys are pursuing actuarial, or you're into BSc, MSc mathematics or statistics, you guys are sitting in the right chair. Because yes, you are studying statistics, so now you know the theory behind that. Right? Okay, but when it comes to let's say there's an insurance company, and that insurance company needs data. Right? And the data is coming, the data is there is one point in the data that talks about the height and weight of the customer. Right? Okay, and the customer is, let's say, there is a crowd that is diabetic, or the people who are suffering from particular ailments, and there are people who are healthy. Right? Okay, so if I get this data, and I want to try to if I want to create a correlation plot between the height and weight and the ailment, will there be correlation? I mean, I don't know. There might be a probability that yes, there is some correlation. But then if these small things help us derive the insights from the behavior of the customer. So let's say there's a customer, and I give you a very simple example. Let's say there's a customer, and the customer comes to a showroom, and he purchases a car, and he is supposed to buy car insurance. He purchases car insurance, and then he's all set. What is the probability that the customer is a reckless customer? He drives carelessly, and there's a high chance that his car will ram down somewhere, or probably he'll meet with an accident, and we are supposed to pay the claim. So if I know that this is going to happen, so imagine the power the insurance company will have in, accommodating their premiums, risk patterns, understanding the risk parameters, and then deciding the policy. They will be able to make more informed decision. Today in Actuarial, we have lot of risk management parameters, lot of toll gates out there through which we are able to calculate and predict. But then if we are able to do something around this, it opens a big scale of opportunity across. So in US, in the mark, if I talk about United States, they've started using some kind of gadgets that will be fixed into your car, that will actually throw the data of your driving pattern. And if you're a careful driver, you drive carefully, the insurance company is going to pay you a lot of incentives for that. As in, they'll reduce premium a little bit, they'll give you more NCB, all that kind of factors. So it's just not about insurance, it's about credit card as well. I'm a new customer, I never purchased any card, I don't have any loan history as well. How will the bank decide that this customer is a good customer and I should give him a credit card? Right, another example, there is an ATM on the road, right? Okay, and that's a very busy ATM. So on a holiday that is approaching, let's say the festival is approaching, what amount of money the bank should think of putting into the bank, putting into the ATM, so that the customer complaints can never rise beyond 10%. Right, so these are the couple of business examples that analytics target and analytics answer. Right, okay, another example from the aviation industry, how many I mean, seats should I oversell, so that if there is any cancellation, I'm able to accommodate the customers, and I'm able to maximize my revenue. All right, so these are some of the examples that analytics answer. So the field is interesting, and as you face business problems, and as you actually get into the deeper of it, you need data, so that you can support your decisions, you can find out the pattern, and basis that you can design or develop your hypothesis, you can test it and then predict. That's what we do in the field of data science. Okay, but then now there are two things in this. One is that there's a team of data scientists or data analysts or business analysts who create data visualizations, who create plots, send it to the data scientists. That guy is responsible for analyzing the data and finally predicting. Now the prediction is in front of the senior management team, as in the business management team. So senior management people who run the company, who are the key decision makers. Right, okay, so they are the ones who are supposed to decide. So as a data scientist, our life is all about numbers and predicting, and making sure that yes, whatever we predict is absolutely correct. Right, I give you a very simple example, if you can relate it. The world, I'll say it's a very small world, but then it's a very interesting world. I started my career from a stock market. So it's a beautiful world wherein you have simply one thing: data. There's the name of a company, there's a stock price, it will increase or it will decrease, it will go down, the market is going to, this particular stock will bullish, or this particular stock will go bearish. How will I decide? This is all prediction at the end of the day. Right, so if I make accurate predictions, there's a high chance that I as a stockbroker will make a lot of money. So there is no deniability that, as we see here, there is no deniability that yes, every industry has tons of data. And the most interesting data that we see is on the Flipkart and the Amazon. If you go to a small store that is next to your street, it's kind of a supermarket, and then you go to the store early in the morning to buy milk, and you see that the milk, breads, jam, fruits, they're all stacked together. Why they're stacked together? Because there's a high, it's more likely that the customer who is buying milk is more likely to buy bread, jam, eggs as well, right, for the purpose of breakfast. So if he grabs one thing, there's a high chance that he will grab the rest of the things and will make more money. Right, okay, so that's how the world appears to be today. If you look into Amazon website or Flipkart website, so the customer who has purchased this has also purchased this. The customer has viewed these items, have also viewed these items. This is predictive analytics. They simply predict that if you are purchasing this, you should buy this, and this. Right, okay, and we see that very clearly on Amazon and Flipkart website. So this power is driven by analytics. I'll use simple words. I'm not going to use machine learning and fancy names because they appear to be more confusing. So but then this is driven by the power of analytics. Okay, so with this we'll move ahead. So the field looks interesting. Data is everywhere, and I like that data. Yeah, I'll answer that question in a moment. Okay, just save it for a couple of minutes. So data is everywhere. The field looks interesting. Now, the thing is, the question is, what is a data science, and why data science? So I'll break this one. You have data. You know what is the data, right? Let's say you have a restaurant, and the lot of customers who come to your restaurant, they order food, and what is being ordered by whom, and you have months of data. So can you analyze the taste preferences of the customer, and can you predict what is liking, or what is the liking of this particular customer? So if this particular customer who has this, whether he's a non-veggie or a veggie, and then he prefers this, so he's more likely to buy this particular product, or probably I can recommend him, because customers do ask for recommendation. What is good in this restaurant, right? So if you recommend the correct thing, the, you're more likely to buy that customer. That customer will always come to you, right? Because he'll like the taste, he will like the ambience, he'll like the customer service. So you will get a customer for life, just like we get subscribers on YouTube, right? Okay, so you have data. Can you apply science to it? That's what data science is in a very simple terms. And what is the science here? The science is nothing but it's driven by statistics, mathematics. These are the two essential pillars on which the entire world of analytics stand. Analytics itself says analyze it, right? And how you're going to do it, you will not be able to analyze it till the time you don't have the acumen. The acumen means the knowledge of statistics and mathematics. Okay, another thing, right? So as you see here in this particular side, that actually data scientists, these people are in demand. And the reason why they're in demand, because we don't have so many professionals in the market. I tell you my story. When I started working for GE in the 2006, so at the time it was GECIS, GE Capital International Services. And when I moved into analytics next year, 2007, after working in operations, so I used to wonder why people don't talk about it. There was no resonance. I don't remember the year precisely, but I believe 2006, around 2006, YouTube was developed. So there were not, a lot of videos on Excel or SAS, those kind of stuff. And then we used to wonder why people do not talk about it. This is such an amazing field, because you need to have tons and tons of common sense, analytical thinking, and amazing common sense. That's what you need to start. And moreover, yeah, learning statistics, maths, programming, all the stuff, all these things need dedication. That's it. I tell you, as a matter of fact, I have seen a data scientist working at Amazon, and that guy was a graduate in history. Yeah, there are stories in the market. And I'll not be surprised if I come across such kind of stories more often. But then yes, it is understandable that people who have analytical brain, the people who come from STEM degrees, as in mathematics and science degrees, they are more inclined towards this field. So one thing, that the figures are very fancy, everything is good, but then you need to have genuine interest either in the field of actuarial science if you're pursuing actuary, because that is also a data, and you are actually a niche data scientist. But then just understand, actuarial only work into insurance, and you guys as data scientists will be working across all the domains, be it insurance, banking, pharma, retail, any sector, so to speak. Okay, now salaries are good. Media houses, big websites, they are talking much. In fact, LinkedIn 2017 report that was published in December 2017, yeah, so that's the reason it is very relevant. So you can refer to this link and go there. So you'll see top jobs are related to data science, data mining, and machine learning. Yeah, so machine learning and data scientists, these are the most preferred people across the globe, and not just India. If I talk about Indian market, so you guys are sitting in a in an amazing location, because a city called Kolkata, there are a lot of companies coming up with these kind of roles. In fact, they're starting to offer internships. I've seen internship in Actuarial that focuses more into data crunching, right? Okay, so whether you work for insurance or any industry, data crunching is everywhere. And believe me, right now you are using pen and paper and a calculator to solve your questions and answer the problems. But believe me, in the practical world, we need to have system. A laptop or or your PC or your computer is the is your biggest friend in this field. Because if you have any problem, if you have any question, you have a data and you need to answer, it can only be done through systems and the programming languages. Okay, so I'll come down to that now. So this is in the continuation to the previous slide. Yes, so McKinsey and LinkedIn and a lot of organizations are predicting that yes, the demand for data science and data scientists, or in fact analytics professionals, is increasing exponentially. So there will be a time when this field will be saturated. Of course, there was a time when people used to do only MBA, right? Okay, so there was a everybody was on this bandwagon. I want to do MBA. Every next person. Then there was a time then people used to talk about CA. I've taught almost 4,000 chartered accountants in company secretaries since I moved into academia. And then I started, I moved into this field and I started actuarial students training into, training them onto data science and, tools like R and Python. So there was a time when people used to talk about BTech only. In our days when I graduated, from my school and college, so people used to talk about BTech. But today I know what BTechs are doing. My lobby of entire friends, they're all BTechs. But then I chose a different path altogether. But then that's a separate story altogether. So every field, a field grows in the market. Then people come, they start pursuing degrees, they get jobs, and a time comes when the field gets saturated. So what's the point? The point is very simple. If you know this is enticing, this offers a wonderful opportunity, this is great, be aggressive, pursue it, learn it to the core, complete your learning curve, get a job. It's as simple as that. Because sooner you move into this, there's a high chance that you will be into a higher pay bracket, right? Okay, in fact today in Bangalore, I tell you this training scenario, that in Bangalore, if somebody knows machine learning and he can train the people out there, the training companies are willing to pay that person almost 200,000 per week. So that's the demand in the market. Okay, so I'll see the chat just a moment. Yeah, so that's the demand in the market. So who is a data scientist? I'm sure you guys would have heard a word: data analyst, business analyst, and data scientist now. So what is the difference? As a matter of fact, business analysts are the people who focuses more on the business. That's the reason they are called as business analysts. Analyst who can analyze business, okay, who can understand what is good for the business, what is bad for the business. Okay, so they can be the people who coming from management degree, they're from the marketing, all those kind of people. Okay, but data analyst is a person who typically, who has the data, who knows that where the data is kept, he sources that data from a database, creates visualizations. I have a business problem, how to actually break that business problem into simpler parts. That's what the data analyst will do. So he will run the descriptive statistics, he will create 5 point summary statistics, he will create a histogram, box plot, all that kind of stuff. Okay, and then with the help of visualization, he will send all that data, all that stuff to data scientist in a bigger organizations. That's how the roles are diversified. But then data scientist is a person who does all these kind of jobs on his own. I mean, he's capable enough to perform all these kind of jobs on his own, and his job entails predicting. So what is going to happen next? Data analyst only talks about what has been done in the past. It's like, if I compare, I'll give you a very simple example if you're not able to understand. Chartered accountant, a role of a chartered accountant is simply, record all the transactions or all the accounting transactions that have happened across the year, and show it in a very fancy table that is called balance sheet and profit and loss. Chartered accountant does not believe in predicting. There is a concept called forecasted balance sheet. Okay, but then that is not driven by statistics, I would say. Okay, so they can only forecast up to a certain extent, that basis this is what we can expect, that this is the X amount of money you guys can make in the next coming year, right? But then that is, may or may not be true. So what exactly, he says in the forecasted balance sheet, for me it is more like a hypothesis testing. You have created a hypothesis that this is the amount of money I'll make, and then probably, I will go back to the data and I'll, create an alternate hypothesis and I'll run my test, just to, analyze that, whatever you say that is correct or not. Okay. So predicting is the key area of a data scientist. So there are roles like predictive modelers, or basically, predictive analyst. There are people who are called as machine learning engineers, or basically machine learning, experts. Their job is simply to predict, to run algorithms on the data, should find the predictions, check the prediction accuracy, whether this is accurate or not, and if everything is good, just share the story across the management team. So here, if I talk about your skill set, because that is going to be the next level of discussion, uh, what should I know? That's the biggest question. What should I know? I'll tell you, first thing, that is the primary and the most elemental part in your profession is the communication skills. See, as an actuarial, or as a graduate in mathematics or statistics, if you go for an interview and you're not able to explain what have you learned so far in your academic life, I mean, then what's the point if you cannot talk? So you possess tons of knowledge, but then you cannot simplify, you cannot, convert it into simple language, then everything is a waste. So in fact, in actual, in insurance companies as well, you guys know the technical side, you know how to calculate the premium, but I, as a customer, I'll ask you whether I should buy this health insurance or not. And if you start telling me all the technicalities, I mean, this is of no point to me. You just give me a simple answer, yes, no. That's what customer is interested. When I used to work in the stock market, and I used to sit with the equity research team, so they used to talk a lot of technical jargons, a lot of technical words used to be there, and they used to flow in the air. But when it came to customers, or when it comes to investors, so should I invest in SBI right now? Yes, no. Give me a simple close-ended answer. So if you say yes, I'll go ahead and invest my money. If you say no, I'll not invest my money. I'll save it for another company. It's as simple as that, right? So if you are able to explain all the things in a simple, fancy, and attractive language, yes, you are going to retain your customer. So that's where the communication plays the most integral role in your profession. Okay, this is the primary and the elemental aspect. Okay, I'll move to the next. I'll talk about the technical aspect of this profession. See, I give you an overview to this question right now because this is more relevant to your, to this discussion. Analytics, data analytics, machine learning. These kind of jargons are actually being, thrown a lot in the market, being used by a lot of people in the market. But then, ground reality is that all this appears to be same, because analytics word is an overview, it's an umbrella word for everything, until and unless you do not talk about AI. Okay, because there is a very big difference between AI and machine learning. Machine learning is a big umbrella word, sorry, AI is the big umbrella word, where you see machine learning, deep learning, and all that stuff. But when you want to apply regression, or basically a Bayesian methodology onto the data, we give it a very fancy name called machine learning. So machine learning is nothing but it's a fancy name for statistical algorithms, or statistical concepts that we apply onto the data just to find out the probability. Okay, let's say you want to create a standard normal distribution, and you want to calculate the area under the curve, because all you have the continuous data, and the continuous data refers to the height, weight, stock prices, time series data. Stock price is nothing but the time series data, right? Okay, and then you want to calculate the area under the curve, let's say. So what is this? This is nothing but, you can say that, yeah, this is I'm calculating the probability. But yes, in terms of the statistics, you can say that it's like a probability. But in machine learning, the simple word is converted into an algorithm. So uh, data analytics is when you analyze the data and predict. Machine learning is nothing but it's a set of machine learning algorithms. There are a lot of algorithms that help you predict. I'll simplify this when I say that the machine learning algorithm that help you predict. Let's say you have a data, and and that data has a correlation of almost 80 to 90%. Yes, we have data in R. I generally do that when I teach my students, so they know that yes, we calculate the correlation, and then we see that yes, there's a correlation, and there's a linear trend that we see in the data. So now when you know that the trend appears to be linear, so y is equal to mx plus c, or a linear regression is the best thing or the best algorithm that will help us predict. You call it linear regression as a chapter or a concept, we call it algorithm. This is the first and the most primary regression algorithm, or the most primary machine learning algorithm that we apply onto the data. Okay, so you call it concepts, we call it algorithms. Okay, but now when it comes to prediction, what you're doing, you're in fact using statistics to perform that. Okay, so data analytics, that's the reason I said analytics is a big umbrella word in which your data wrangling, data cleaning, data pulling, and then visualization, making plots, charts, and then prediction. This end to end comes into the picture. So without machine learning you cannot do that, or in a simple words, without using statistics you cannot perform that. Okay, so that's the answer to this question. So coming to the skills now, you know don't get overwhelmed. Everything is fine. It's just that it takes time. Of course, you're developing a skill. Okay, there's no course here. Just like in Actuarial, you have a course that you have to clear CDC. So there are 15 chapters. You have to study this, and this. Solve 15 years of papers or 10 years of paper in CA. You have your CA inter, and then 3 years of articleship, and then final. Right? Okay, that's not the way this professional curriculum works. Okay, the curriculum here is very different. Okay, now the thing is that when you learn something, okay, so there in on the internet you will see a lot of course, but then the core concepts are not being explained by each and every course. Either the courses are very theoretical, or the courses are very practical, missing the essence of the subject matter. Okay, so first thing that you need to know, whether you are pursuing an actuary, you are an actuarial analyst, or you are typically an actuary, you should know that you need to code a lot in your life. Please make this point very clear. Whether you come from commerce, whether you come from science, you need to code a lot. Be it in Excel, VBA, you write macros, or you write in R, you write in Python, you have to code a lot. You should be very, very comfortable with coding. If you're not comfortable with coding, please make sure that you become one, because in Actuarial there is no survival. Because I know a lot of profiles, a lot of roles in Actuarial that people are into, they're working, and they have to code every now and then in their current life. Okay, because a lot of automation that happens, right? Okay, in Excel a lot of repeated tasks do happen. So if there are a lot of repeated tasks, I will prefer write a macro code there, and save it in a button, so that I click the button and swoosh, it happens in a fraction of a second. Okay, I tell you the a very basic example. When I used to prepare the dashboard, so I had a very big shop of 350 people. There are 4 businesses, and all that data used to come to me, and I used to collate that whole data, and run the bar chart, and then all that kind of graphs, put it in a PPT, and send it to the site leader. So that was the basic task which I used to do. And the time came when I became tired of all this. They used to be almost that PPT used to be almost of 70 plots, and creating 70 plots or just updating it and then simply copy pasting it is not that easy. So I found out the ways how can I do that. So it took almost 10 to 15 days to write a macro code. So that would actually create a dashboard, and it used to take almost 3 to 4 minutes to run that entire stuff, collate the data from different Excel sheets, and then finally getting the mail ready and sending the email on its own. So I used to do it on a single button. So what used to take me 6 to 7 hours, I did it in 5 minutes. That's what automation is. That's what in fact I talked about. If a machine can do the thing in 5 minutes, was the point of human doing it for 6 to 7 hours. So it helps me relax my effort. I can put that time into more I can prioritize my time into more important stuff. Okay, so you should be very comfortable with coding. With data science we start with R and Python. So the best thing is that you can start with R, because R is in your actuarial curriculum, and R is the most preferred language in the market these days. Okay. Second, and there is no deniability that you need to have a very solid understanding of mathematics and statistics. Yes, it is required, and one cannot shy away with. If you want to tell you a couple of books that you can refer to, I can give you a list of books. Those are called self-explanatory books. Those are meant for the people who do not know anything. But then the only the condition is that you read that book by heart, word by word, and believe me, you'll be able to gain equal amount of understanding that these people have who are typically coming from science and maths. Okay. Third, machine learning. Yes, with the help of, when I say machine learning, it actually includes statistics and mathematics and coding and data cleaning and data wrangling. Everything is there, because the end result is mathematics. Your end result is machine learning. I tell you one thing here. When we get data, so data comes from several sources. It would be in a database, it would be kept in a database, okay, or in cloud, and I just pull the data, and the data is here on my system right now. So when I get the data, the first thing that I need to understand is that I simply cannot go ahead and apply linear regression or descriptive statistics. You know why? Why? Because the first thing first is that you need to clean the data and bring it into the correct pattern. Okay. Till the time you do not do that, you will not be able to run the required algorithm that you want to run and predict. So predicting and applying machine learning, hardly an activity of 10 to 15 minutes. Yes, it actually is. There's hardly a couple of codes that you will write and it will run. Okay. But then the 90% of the task involves data cleaning, creating plots, understanding the patterns, data wrangling. So this, you can say that all this, cleaning up the data set takes 90% of your time. And yes, this is the most frustrating part. And the worst part is that all these courses that are available on the internet, they do not teach this. They will either talk about mathematics or statistics, or they will talk about programming, or they will talk about machine learning. But then this part, you know, you have the data, you have to clean that data, because that depends on the business requirement, how exactly they want the data to be. Basis that you are supposed to clean that data set, nobody will teach you this. Okay. And that's the key thing that I do in my courses, because you should know how to clean the data. If you're able to clean up the mess, you'll be able to apply machine learning within fraction of seconds. But now, you applied a machine learning regression, let's say linear regression, and there's an equation, you got intercept and coefficients and everything. But now, in order to understand that, you need to have that knowledge, you need to have that acumen of linear regression, or the acumen of statistics. You should know what the chapter talked about when you were pursuing CT3, or when you were learning, all that stuff. That knowledge will help you, gain the insight. Okay, so this number is this, so this chart refers to the data like this, so this is homo, this is not, heteroscedasticity is not there, all that stuff. And basis that you can apply. Let's say this is a very, niche example. I give you a very simple example. This is a very sophisticated example. You ran the descriptive statistics, you created a histogram, and now this data appears to be, skewed. This is not normally distributed. Now you know that I read in a statistic that yes, if the data is skewed, I need to apply parametric test or non-parametric test. So basis that you will decide whatever the test you want to apply onto the data, create hypothesis, and then run regression or machine learning algorithm. But then, the theory behind this is statistics. So if I do not know that, nothing will work. So do you want to say that statistics and mathematics are related to machine learning? 100%. You cannot run, I mean, you will know the code. Linear regression in R is known as is in fact, it's known as LM. You apply LM code, you watch it there on Google, you'll say LM in R, you will get to know linear regression. The entire theory is there. People have written amazing articles. But if I do not know, I mean, nothing's gonna work. Okay. Databases, yes, you need to have the knowledge of databases. Yes, because you should know, you should write queries in the in SQL, so that you can pull the data from there. Now I'll tell you one thing as a matter of fact, because in my life I worked almost, in the 11 years only on Excel and SAS. Excel is considered with the pathetic software, believe me. If you talk from SAS, R, and Python standpoint, I will never ever give any importance to Excel. Yes, it's a beautiful software, and there is no deniability that it works like a charm. But the challenge is that as you start throwing big data, as in more data into that, and as you start filling the spreadsheets, Excel goes for a toss. You start running a very simple pivot, it doesn't work. It will crash. You run your macro, the data gets corrupted. You cannot do anything. You have to write the code altogether. So those are the challenges in Excel, and that's the reason R works like a charm. It can handle huge data, right? And it works very easy. So I worked on to SQL a lot, SAS and Excel, but in R and Python specifically, there are a lot of packages. You simply write the code, and you connect with your database by applying the user ID and password, whatever the parameters it is given in the programming language, and you run it. It will automatically pull the data from SQL into R. So I need not go into SQL, write the query, extract the data into CSV file in Excel, and then import it into R. R can directly import. And I mean, if let's say you're creating a new programming language, and there are a lot of databases across the globe, so you should know how to communicate with those databases. Why would I would use an interface called Excel just to pull the data into Excel, then pull the data back into R. So I would definitely prefer doing it like that, because this will save a lot of time. Yeah. And what professionals do, I tell you, as a matter of fact, they will write the code once and they'll keep it forever. They'll run it every time without getting into the nuances, and that's what everybody does. Even, in fact, I also do that. Till the time that doesn't show me a bug, I'm not going to look into that code. So it is working, everything is good, let's move ahead. Because here my job is not to actually see the algorithm and see if everything is working fine. I get the end output, everything is good. Okay. And you should be very good with data visualizations. Yeah, a picture says more than what words can talk about. Okay. So what you can say, that this is this, I see that this number is this, the mean is there, the median is this, and therefore I see that the data is skewed. Forget all this. Show me a positively skewed data, I'll understand it myself. Okay. So you should be very good with the data visualization. And the last thing on the plate is that this is recently been added, and I'll give you the data to support it. Big data is nothing but the data that cannot be fit into the system. Okay, that's what big data is all about. Okay. So let's say your laptop capacity is 1 TB, and you have a data of, let's say, 10 TB. This data cannot be fit into the system. For you, it is a very simple example of big data. But the big data is in, not in terabytes, it's in petabytes, terabytes. Okay. And that's where big data architectures like Hadoop, Hive, Peg, Zookeeper, these kind of architectures, they come into the picture. And therefore you need to have a knowledge of a special kind of database. If, let's say, you are working somewhere, and in your profile you are supposed to know big data, so that's when you need to have knowledge of a special databases like MongoDB, Cassandra. These are the databases who handle who keep actually huge data, and they're very much comfortable working with Hadoop and big data interfaces. Okay. But why big data? The question is this: two important points that support this. Today the world is flooded with a lot of data. Let's say you get a job at Amazon. Okay. And Amazon says that uh, it asks you a very simple statistic, that the Mr. CEO says that just give me the average of the sale transaction that happened at Amazon. In order to find out this particular number, you need to undergo billions of rows of data, and that data will not be in Excel. That data will be kind of a big data. So one thing is this. Second is that if you are supposed to predict, let's say, mobile phones, or basically the electronic gadgets that are being purchased at Amazon, because that's a product that is being sold most, right? Okay. So probably you need to have a lot of data. You need to take a lot of data as a sample, just to be sure that whatever the prediction that I'm making is accurate. So less sample, it will give you a biased answer. But more sample, yes, I will be I'll be better off making inferences about the population. That's what inferential statistics is all about, right? Okay. And that's why you need big data. I'll hold on for a second. I'll ask you any questions up till here. Let me know in case you have any questions. So I'll move on to the next slide. Okay, just a moment. Yeah. So I'm curious. I don't know whether you guys are curious or not, but then I'm curious to know that how is the work like? What I'm supposed to do, and how is the work like? So I'll give you a very simple insight, step by step. So let's say I have a data, and I work in a retailer store, so I get the data of a retail mart, and I'm supposed to predict the sales. Okay. So when I'll get the data, I'll understand all the variables in the data. Okay. So when I say variables, so let's say there will be a couple of variables. Let's like the product ID, name of the product, the weight of the product, visibility or the on the shelf, right? Okay, the product that is more visible, you imagine yourself as standing in, Shoppers Stop or Big Bazaar kind of, stuff, sorry, on a place. So the product that is more visible is more likely to, get sold. If you, nobody does that, even I don't do that. When I go into a store, I will not put my hand deeper into the shelf and I'll pull the product. So what is I see there at front, I'll simply pick it up, right? Okay, so that's what visibility refers to. Okay. And the store size, store area, number of customers visiting, ambience of the store, although that is not relevant, but that is also included there. Okay. And then the amount. Okay. So all these things in machine learning, we call them features, but in simple analysis, we call them, variables. So first thing is that when you look into the data, the first thing first is that you're supposed to clean that data. And you know there is a sale, there is a quantity, and there is a, price per unit. So you can create another column that is called the amount, right? So quantity into the price, and you will get the sale amount, right? Okay. So you can create, that's what we call as, introducing, transforming the data wrangling, and then, first of all cleaning, and then doing the data wrangling. This part takes 90% of the time. And the people who say that a data analyst need not have business knowledge, sorry, I beg to differ, because till the time you do not have the business knowledge, you will not be able to make good decisions. Okay. So you need to have good amount of knowledge about the business, or else you need to apply common sense out there. Okay, because there will be a high probability that the data will have missing value, or the data will not have the correct value. There will be outliers in the data. So how to normalize all that, how to bring the data into a standard position? Refer to the standard normal distribution if you guys ever studied, right? Okay, why do we need a standard normal distribution with the mean 0, standard deviation 1? Right? Because if the mean is 0, a lot of things are actually set, a lot of things are decided based on the z value. That's what you guys are called a z score. Okay. So how to actually standardize all these things so that everything falls properly into the place, and then I can move ahead and I can apply machine learning algorithm. So first thing first, you get the data, you study the data, you clean the data, you simultaneously you start writing your hypothesis so that you can test it afterwards, and you can support your decisions, because that's what the business needs. And then after cleaning, applying wrangling, running descriptive statistics, understanding the mean, median, mode, and all the stuff, and then finally applying machine learning. So machine learning, before I apply machine learning, these are the all steps that I will perform. For that, I need to have a knowledge of programming, and hardcore knowledge of programming, because it's not going to happen like that. You clean the data in Excel and you bring it into R. Yesterday in my session, somebody said that it's better to clean the data into R. I said no, I mean that's not possible, because it's not the way things work out. So if you're working in R, you should know how to clean the data in R. If you're working in Python, you should know how to clean the data in Python. Okay, so you clean the data, and then you can run 5-point summary statistics just to look at the shape of the data, distribution of the data, and basis that you can decide your test. Okay, and then the final stage comes the machine learning, and then you apply your machine learning. I give you a very funny example. I read it somewhere that a man went into an interview, and that was basically a machine learning role, and that the person asked, what is 16 plus 2? So he said 8. Then he asked again, so what is 16 plus 2? He said 11. Then he asked again, what is 16 plus 2? He said 15. Then he asked again, what is 16 plus 2? He said 18. Good, congratulations, you're hired. Because that's how machine learning works. That's how machine learning works. If you do not believe me, review, or in fact visit YouTube and see the interview of Sebastian Thun, the guy who created Google car. So he told in his interview that when we were creating this Google car, so we because how humans learn, by seeing, by looking at it, by observing it. So that's how we wanted this car to learn. And therefore we used to take the car early in the morning in a desert, and there was a car, and we used to drive that car. And in totality we drove for almost 40,000 miles. And after this Google car was able to learn how to drive. So you need to, you need to put a lot of data, you create a lot of samples, run it across several times, so that the machine learning model is able to inculcate all the features of the primary data. And then when you start predicting onto a new data set, your predictions will be accurate. Okay, although this is a very funny example out here, 16 plus to 18, but yes, that's how machine learning algorithms work. Okay, so that's the beauty of it. But then yes, it is typically meant for the people who, who are highly interested in this, who actually want to see the world on the other side. If I predict something, will it actually work or not? And when you see your predictions work, believe me, you are the happiest person on the earth. So now you have done everything, you have your predictions and everything in your hand, and you're excited to share your story to the senior management team. Create an amazing presentation. Support it with your facts, with your statistics. Tell them your hypothesis, and then let them know in a form of a story, so that they are also attracted and they say yes to the forecasting that you have created, because all these things are required to develop a business decision, to create a strategy, to probably change the strategy in the business. Okay, heat maps. Heat maps are nothing but the colored maps. Okay, wherein there is a light color, there's a high color. The high color simply gives you simply a view that in this particular area of a product is being sold more, just like Swiggy. Okay, so I've seen for the first time I saw Swiggy in Kolkata. Right now it's there in Jaipur as well, but then they're not serving in every location. So if I create a heat map of the orders, or basically the customers, or basically these people who travel and deliver the food, so they will be able to create basis a color pattern. So where there's a dense color, so this particular area is something that we cannot miss onto. So probably they can fasten the order processing. They can probably offer goodies, or probably offer more discounts through their apps. If you order this up till this time, so probably you'll get this is additional. So that's how they can make more money, they can make more sale. And how do you decide? By just looking at the data, right? Okay, I hope you're able to understand what exactly I'm talking about, right? Any doubts, any questions that you might have in your mind, or you want to ask something to me, you know just let me know. Please put it in the chat, and I'll be glad to answer. So that's the real life of a data scientist. That's what we do in our day-to-day work. So we get the data, we clean the data, wrangle the data, apply data mining, try to find as much pattern as we can onto the data, and then we go ahead and apply machine learning, right? Okay, so the entire work in a busy day is actually in between of these. Okay, right? Okay, the next thing is that, yeah, so here comes the attractive part. So it's amazing that I make I see that the skill and the role is good, but what about the money? I know that in Actuarial people are awarded with good amount of money. So how about data science? Data science is no less. I'm not going to compare with Actuarial. There's no point of comparing apples with oranges. Okay, these are two different domains altogether. But yes, if you look into the statistics, 2018 salary survey says the median for R is 14 lakh approx. Okay, and this data is available on Google. It's available there, it's taken from there. So there is nothing that I am writing on my own, so you can go ahead and verify each and everything. Okay, you go to Analytics Vidya, there's a 2017 salary survey. These are the slides from there, so the entire source belongs to them. I'm just sharing it with you guys. In fact, 2018 salary survey is going to come on their site soon. Generally they launch it in the month of May and June somewhere, so it's going to be there very soon. But yes, if I refer to the last year, so if you know big data and machine learning, you can expect somewhere like 14. This is the last year. But today, 2018 analytics salary survey said that median salary for our program is 14 lakhs. So yes, companies are offering good amount of money. Companies want that the people should come for the interview. If you know little bit, I mean, you should come for an interview, you should apply for an interview, right? They are more than inclined to train you on their business aspects. So they will do this on their own. In fact, couple of insurance companies like Aon, these kind of companies are doing this. I've got a request from Aon in Delhi. They want us to conduct a 3 to 4 day workshop on R programming. They want us to actually make them understand R, so that these guys can be comfortable when it comes to working with R. So companies are taking a lot of pains to do that. But then if you know R, just R alone, so 14 lakh median salary last year, it used to be 10.4. So the bar has raised like anything. So as many tools, you get more money. Okay. But then I am a fresher. This is general, but I'm a fresher, I don't know anything. So if you know this, whatever I've shared in the skills screen, or basically skills PPT at the time, so you can expect somewhere between 5 to 6 lakhs. And I'm being very honest, do not expect that much, more than that. You expect the lowest, but if you're able to manage to get more money, I mean, that's a charm. That's like an icing on the cake. So that's good. But then yes, somewhere between 5 to 6. I'm being very honest with you. Okay. Next, yeah, Kolkata is there. You see there in the in this particular plot there. So Kolkata stands at 9.5. Yeah, Kolkata is offering 9.5 lakh, this much amount of money if you know R, Python, or basically machine learning, and you can actually write algorithms, or basically use algorithms, write codes, and do the task that the company requires. So companies are willing to pay the money in Kolkata as well. So Mumbai takes the lead in the market in this current year. Also Mumbai pays the highest. Yeah, but then the money is offered to the person with the correct skill, right? So what lies ahead? So the thing that lies ahead is machine learning, big data, and of course coding. Without coding, you cannot do anything. So when I say machine learning, maths and statistics by default included into this, right? And this is the trend. You should actually look into this. So this is the trend. Major jobs, you can see here, the major jobs are related to R, right? Python and machine learning is improving a lot. So there are a lot of jobs that are coming, but then SaaS is going down. SaaS is being preferred by big companies because it is a paid cost, it is a paid software, and the amount is huge, more than 1 CR or something like that. And therefore, not every company is able to afford SaaS, especially startups. And that's the reason, startups prefer R and Python, being open source software. You can download it from internet and you can start working. So these are the companies who are actually using R and Python. So a lot of companies, big companies have also started using these open source softwares. They're also getting comfortable. They're training their employees. They're looking for training vendors who can train their employees. So the market potential is huge, and also R is there in your curriculum as well. So that's when the intercept happens, and you'll be able to get good exposure in Actuarial as well. Any questions? That is it from my side, guys. So uh, I'm waiting for you to ask questions in case you have regarding the stock market. And let me actually see that question. Let me see the questions here. So how can I actually enter into the Indian stock market? I tell you, as a matter of fact, uh, there is something that is called investment actuary. But in India, yesterday a student was also asking, but in India we don't have such kind of roles, because most of the roles are actually limited to the people who pursue their MBA from top business school. They go as investment advisors, or basically portfolio managers, or mutual fund managers. Okay. CFA is there, but I am a CFA. But then the challenge is that with CFA, an individual certification is not going to work until and unless it is coupled by FRM, or basically chartered accountant, or actuary, right? Okay. Till the time you don't do that, I mean, that's not the way things work. But actually, if you're looking for data analysis, there are not very good amount of roles in the field of stock market as an actuary. But yes, as an actuary, yes, you can say a lot of roles out there in the banking sector as well. So they are there, but not quite a bit. Yeah, but then as a data scientist, you can expect a lot of roles out there, because yes, companies are stockbrokers are throwing a lot of offers, who can analyze data, because data is everywhere, right? Okay. So that's the core thing. In fact, insurance companies are also offering a lot of positions in the field of data science. See, there are a lot of institutes across. So S Cube itself is doing its they're training students. they're preparing students for the data science roles. So I know SCube is there, and Sankiki from Delhi, those guys are also doing. So these are the two major institutes. They are performing data science. In fact, whether you call it fortunately or unfortunately, I am their data science trainer. So I train the students. So my job is to actually train them, to prepare them, so that they can start looking for the job, and they can get the job. So I'm preparing you for the next level opportunity that is there in the market. And if you want to learn online, so there are a lot of Coursera is there, Udacity is there, if you want to start with that. In fact, in the next couple of months, I'm also coming up with a free course, because there's no point of teaching them everything from scratch. So I'll give you 20 to 30 hour of content. You watch it yourself, and then you can enroll, so that I know that you have covered your basics of R, Python, or statistics. So I'll take you to the next level, that is the advanced level, by directly applying machine learning out there, working out of the advanced coding part, so that the learning curve can be easy, and you guys will be able to gain more interest. So that's a effort that we are going to make here. Any questions? All right, thank you so much. So that is it from my side, guys. Thank you for listening me with a lot of patience. Let me know in case you have any questions. Thank you. I'm disconnecting from here. Have a good day. Bye bye. Take care.